We are going to use models to show the division of fractions. We are going to interpret the quotients. What is a quotient? Who can tell me? Ashlyn? The answer to a division problem. So we're going to find the quotients of fractions and interpret the remainders in real-world problems. So let's look at 1 and 2 at the bottom. This is our review. You have done fact families in the past, especially when you were learning addition and subtraction. Today we're going to do a multiplication and division fact family for number 1 and for number 2. Let's review a addition and subtraction fact family. Let's say I have 1 plus 2 equals 3. What is another fact in that fact family? Who can tell me? Okay, so 3 minus 2 equals 1. What's another one? Ashlyn? Yep, 2 plus 1 equals 3. And? Yes, 3 minus 1 equals 2. So my family is 4 problems, and it is using the same 3 numbers every time, just in a different order. Does that make sense? Yeah. So you're doing multiplication and division fact families with these 2 models. So I'm going to give you 4 minutes to come up with the fact families for both models. Yes, sir? For addition and subtraction, yes. For just addition, subtraction doesn't have that. Subtraction, the order matters, and division, the order matters. Multiplication and addition, it doesn't matter.
So we're doing multiplication and division.
Correct. So multiplication and division for 1 and 2, guys. See if you can come up with the fact family. 4 minutes. All right. Who can tell me what multiplication problem they started their fact family with? Okay, she says 6 times 3 equals 18. We're multiplying, not adding. What is another multiplication problem in this family? 3 times 6 equals 18. Okay, what about my division problems? 18 divided by 6 equals 3. And the last one? 18 divided by 3 equals 6. So we used the same 3 numbers in each problem, yes? That is our fact family. Who can tell me the multiplication problem for number 2? Seven times 2 equals 14. Who can give me another one? 2 times 7 equals 14. Who can give me a division problem? Angelina? 14 divided by 2 equals 7. And Logan? And there is our second fact family. Does anybody have any questions about making these fact families? Because we're going to see how they are related when we are doing fractional division. Does that make sense? All right, turn the page to page 44. And Mr. Moore is going to come introduce the lesson for you.
Okay, guys, we're going to look at this division piece using the arrays that we've been talking about to try to help you visualize what is going on as we're doing these division problems. Because division of fractions is a really complex subject that just mathematically doesn't make a whole lot of sense. And we'll talk about how we're going to approach that in a minute. But let's at least get this concept down so you can understand what's happening. And it has to build on what we just did with those multiplication facts. How do I write them, and how is multiplication related to division? So let's look at our unit square models. If we divide it into 5 equal rows and 4 equal columns. And then I just color in just the 1. So if I look at this as the answer of it, what would the answer be? How many blocks are shaded out of the total? Mahana? It's 4 by 5. 1 out of 20. So that represents the total that is shaded, 1 out of 20. Does everybody see that? Anybody not see that? Okay, so when we did area, area is always what? How do I find the area? Excellent, thank you. Length times width, right? So saying that this is the answer of 1 out of 20, we'll now call this the length going up and down. So if I look at it with just this first column as my length, with just the 1 being shaded, what is my length in this? 1/5. Does everybody see that? Everybody tracking so far? So now I look at the other way, because I did length times width. So then my width is now being represented as 1/4. Everybody understanding how we're breaking this model down so far? Anybody not see it? Thank you for being honest. So we have one that's not seeing it. So if I look at the entire picture, I have 1 out of 20 blocks being shaded, correct? If I look at my length, the up-down, I have 1 out of 5 that is shaded, correct? If I look at my width, I have 1 out of 4 being shaded. Now putting this into our equation, what we now see is they did it, ironically they did it backwards. So they did the model, area equals length times width, but then they wrote the equation in reverse. So length times width equals the area. Does everybody see that? So if I took 1/5 times 1/4, my answer would be 1/20. Everybody good with that? Anybody not good with it? Okay? So that's our starting point. Now, what we just did was our multiplication families, right? How are multiplication and division related? Good. That's okay. Thanks for putting your hand up. Yes.
That you can use the same number.
And I do what?
That relates to answer. Like,
So give me an example.
1/4 times 1/5 equals 1/20th. 1/5 times 1/4 equals.
Oops, careful. Don't give me all the answers because we're about to do that. Let's use whole numbers. So if I said 2 times 5 is 10, how could I make that into a division problem? What were you going to say?
I was going to say that multiplication and division are related because they both have groups, and sometimes it's easier adding groups or subtracting groups.
Good. So they're related because they both have groups. Go ahead.
Because they're opposites.
Because they're opposites. It's almost like a little birdie whispered in your ear or something. They're opposites, right? So for my example, 2 times 5 is 10. If I want to turn it into a division problem, I say 10 divided by 5 is 2. Does that make sense? So now, using these numbers, we want you to write 4 multiplication and division sentences. I'll give you a hint. Here is number 1. So use that as your base. Give me 2 multiplication, so 1 more multiplication, and then rewrite it twice as a division problem. We'll give you 2 minutes. You can work as a table, go. Okay, so I gave you the first one, 1/5 times 1/4 equals 1/20th. Who had a second one?
1/4 times 1/5.
Awesome. Okay, so who was able to do the division ones?
1/20th divided by 1/4 equals 1/5.
Excellent. Then who can knock us home, Jaden?
1/20th divided by 1/5.
Awesome. Anybody see any problems up here? Any issues?
No.
They caught it right away, first period. Yes?
1/20.
Okay. So is that a problem? Are you saying that's not mathematically correct?
No, that's correct.
Yeah.
You usually put dots instead of X's.
Thank you. Why did no one else catch that? Are we using X's anymore, guys, for multiplication? Because we're about to get into a whole lot of variables, and our most common variable is X. So if I'm seeing X's up here, I'm thinking variables. I'm not thinking multiplication. So we should always, guys, at this point, be using dots for our multiplication. Man, first period, they caught that right away. I'm a little disappointed in you guys. Have to admit. You did, but hold on. Guys, one at a time. Yes.
Because all the papers and sheets we worked on, they all still have the X, so it just will become more confusing where the papers start changing.
Hopefully the papers will start changing. Again, this is a new curriculum for us. We've been trained on it, but I'll be honest, I have not looked through the entire year's curriculum yet. We're planning ahead, but hopefully they will start using it in the textbooks as well. Okay. Now, describe how does the model show the division of fractions? How does our model show division of fractions? Anybody? Sophia?
The shaded area represents the fraction 120 because one rectangle is shaded out of all of the 20.
Good.
Oh, do I keep going?
Honestly, if you kept going, you probably would have the whole description.
Oh, the height of the shaded rectangle is 1/5 of the height of the model.
Okay.
And then for length is the width of the shaded rectangle is 1/4 of the width of the model.
So how does that show the division of fractions?
Because the squares and the one shaded.
The square is one is shaded, but it's also the order, right?
Oh yeah, the columns and rows.
The columns and rows. Because the columns and rows give me my whole picture. So when I divide the whole picture by either the columns or the rows, I get the other one. Make sense? Okay. We do have a definition we need to add in. Break out your highlighters. Here's our definition. It is positive rational number. So a positive rational number is a number you can write in the form of a fraction a over b, where a and b are both whole numbers greater than 0. So a few pieces on this that are really important. One is we're only working with positive numbers, so those to the right of 0. The second is they are rational numbers. That means they can be represented as a fraction, a over b. The other part is a and b are whole numbers. So at this point, we're not working with fractions and decimals in our fractions. At least not for today. We'll see. We were looking through the whole division lesson today, and they bring in complex fractions. I personally don't feel you guys are ready for that, so we'll see. Maybe you'll amaze me. So, Austin, you know about complex fractions, right? Complex fractions? Uh-huh. Because he's already done all of 6th grade math, so he doesn't need to do anything. He's not learning anything here. So, Austin, complex fractions? Don't worry about it. I haven't given you the definition yet. So we will give you the definition. Just want to make sure there's something I'll be able to teach you. So we talked about that. The division model shows it. The parts are all represented. In the model for our area equation. Area equals length times width. And once I have that basis, that gives me my multiplication facts to be starting to be able to rewrite them as division. So we have the multiplication and division families. Does that make sense to everybody? So leave that up there for a second so you can copy. You should have this written down in your module. If it's written on the board, you should have it in your module. Liam, you okay? I'm about to change the page and you hadn't even started writing that yet. Okay, next one. Here is a chance for you guys to show that you understand what we're doing here. So I'm going to actually give you a couple of hints. Number one, think back to the models we used for multiplication yesterday. And rather than leave this wide open, I'm actually going to give you numbers. So we're going to use the numbers 2/3 and 2/5. So using those two fractions, see if you can draw a model and then write a multiplication division fact family, in other words, 4 of them, using those numbers. So if you use these, you should be able to get the answer of what it is. Then you can use the answer to write your multiplication and division facts. So you may work together as a table. We will give you guys 6 minutes. Go. Guys. Okay, so our model. If I just did my one model, kind of like we did with multiplication the other day, if I've got 2/3, I'm coloring 2 out of the 3. Then the other way I would do as 2/5, and now I'm cutting it into 5, 2, 3, 4, 5, and I'm still just coloring 2 of them. Oh, I went the wrong way. I'm going this way on the 5. So ignore that part of the hash marks. I wish I had my little eraser back. Ignore that part because I went the wrong way. So what we're looking at is we've now made how many different sections? 15. How many of them are colored in twice? 4. So that gives me my first multiplication fact. If I did the 2/3 times 2/5, I get 4/15. So then I can rewrite that one just use the other way. Which property says 2/5 times 2/3 is the same as 2/5 times 2/3? What's that? Commutative property multiplication. So commutative property multiplication says, doesn't matter which one I multiply first, I still get the same answer. Now I can turn this into a division fact by starting with my answer, 4/15, and dividing by 2/3, and then 2/5. Is everybody okay with these? Why not? What's confusing? Hold on. That whole thing? Because do you agree that this whole box would be 1? Okay? So what I did was I said, okay, in my length, I'm going to divide it into 3, and I'm going to color 2 of the 3. So this is 2/3 for my length. Are you good with that? Yeah? And then I said for my width, I'm now going to divide it into 5, and I'm going to color 2 of those. So 2/5 is my width. Are you okay with that? And we already know for a rectangle, area equals length times width, correct? Yeah. Okay? And I can see I only had 4 boxes that had both of them. Do you see that? And when I took all of it together, I had divided this now into how many boxes? 15. I can.
That'd be a lot more when you Will you change the colors on it? Please. Please. It looks
Okay, to help you see that it's going the other way. So here was my, which way did I go? 2/3 going this way. And then I had the 2/5 in blue. So I was dividing it into thirds this way. Does that help it make it a little more clear?
because you can see now.
Now you can see which parts have the double. Although I kind of doubled over on the same color, but. The bottom line, guys, is this part right here. Is everybody okay that all of those are equivalent expressions? In other words, they all mean the same thing. Everybody good on that? Liam? What are you good on? Are you good that all four of those are equal? Okay. So now we're going to have you guys turn to page 53 real quick. Turn to page 53. Because there's a definition here we need you guys to have. Because we're going to kind of introduce this a little differently than they are in the module. And this definition is really important for this introduction. So, on the side, you can see this take note. Break out your highlighters again. Page 53. So, a reciprocal or a multiplicative inverse, it's actually the same concept. Two names for the same thing. Is one of a pair of numbers whose product is 1. So a reciprocal is saying a number times another number that equals 1. Okay? The multiplicative inverse of a number a over b is the number b over a, where a and b are non-zero numbers. Okay? In other words, if I have a fraction, we'll say, for example, 2/3. Its multiplicative inverse, all I do is flip it over. So instead of 2 over 3, it's now 3 over 2. Why is that? Because if I multiply 2 times 3, that is 6. If I multiply 3 times 2, that is 6. 6 over 6 equals 1. Hence, a reciprocal is the number multiplied by its inverse to get 1. Huge mathematical concept. All you're doing for a reciprocal, to find the reciprocal, is I flip the number over. So the reciprocal of 1/3 would be 3 over 1. The reciprocal of 3/5 would be 5 over 3. The reciprocal of 18 would be, good job, 1/18. Make sense? Okay, so it doesn't matter what the number is, it always has a reciprocal, and I find it by flipping it over. Is everybody okay with that? Good. So we're going to use that concept. Let's go back in our module now to page 46. Now I will be straight up with you guys. This is how I normally try to start my introduction into division. I will be honest, having taught this last period, I do kind of like this whole thought of getting you used to the multiplication family and showing you multiplication and division are so closely related to help you understand it. But I think this model is actually going to do a better job of helping you understand what's going on. So if I have 6, a group of 6, and I divide it into 2, what am I going to get? How many groups are there? 3. Make sense? So my 6, I divide it into groups of 2. I end up with 3 groups of 2. So we write that as 6 divided by 2 is 3. Does that make sense to everybody? Oh, lunchtime. We'll pick up after lunch. Okay, so right before break, we were talking about how we took 6 divided into groups of 2, and that made 3. And everybody was like, that makes sense, right?
Yeah.
So 6 divided by 2 equals 3. Is everybody good with that? Okay?
Yeah.
Anybody not good with that? I mean, honestly, you should learn that in like 2nd grade. Now, here's where it gets really fun. Does everybody agree that 6 divided by 1/2 is 12?
Yeah.
Does that make sense?
Yeah. Because then you just go over 1 and then.
Oh, good. Someone's been taught how to do this. Here's why this makes sense, guys. If I take my 6 and I divide it into halves, how many do I end up with? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That makes sense, correct?
Yes.
So mathematically, how do I do that? The end? Dividing by half doesn't make sense, does it?
No.
It really doesn't, guys. And I'll be honest with you, mathematically, it doesn't make sense. That's why we introduced that concept of a reciprocal to you. Because it doesn't make sense mathematically to divide by a fraction. Just like we don't actually divide by a decimal. So instead, what we do is we use our multiplication family. We say, instead of dividing by 1/2, I'm instead going to multiply by the reciprocal. What's the reciprocal of 1/2? 2/1. Awesome. Thank you for keeping the 1 in there. Remember, when we're multiplying fractions, I have to have them both as fractions, right? So I put the 6/1. I now have 6 times 2 is 12. 1 times 1 is 1. 12 divided by 1 is 12. Does that make sense mathematically?
Yes.
Is it the same answer?
Yes.
Is it in the same family?
Yeah.
Yeah. That's why we spent all that time at the start of the period going over your multiplication families, how multiplication and division are related. So they are related. Instead of dividing by 1/2, instead I'm going to multiply by the reciprocal. So we have 3 math terms here we need to make sure you understand. So if I have that we're using our equation 6 divided by 1/2 equals 12. Identify for me the dividend, the divisor, and the quotient. So many D's. So let's use our highlighters. We actually have the definitions over here. For any of you who may have forgotten them. Dividend is the number divided into equal groups. The divisor is the number that divides the dividend, or how many groups it's going into. And the quotient is the result of the division, or the answer. So that's your 3 pieces. If I look at my equation, which one is which? What number is my dividend? Yes. 6. Excellent. Because that's how many groups I'm dividing up, right? What is my divisor? Nope. We're doing this one. 1/2. And what is my quotient? 12. Is everybody okay with those? You understand all 3? Good. Let's go to the next page. Who did? Who said no? Oh, it's Melinda. She's just being hard. What are you confused about? Thank you, Callie. Okay, we only had 1, so I think we're okay. Now that you understand our divisor, our dividend, and our quotient, and what we're doing when we're taking a larger quantity and dividing it, we're going to use an example using trail mix. Okay? So I need to now determine how many portions I can make if I use different measuring scoops. So on my first problem, I'm going to divide it into 1/2 cups, then 1/4 cups, and then 1/3 cups. In all cases, though, I'm using 4 cups of trail mix that I'm dividing out to see how many portions I get. So using what we've taught you so far, I'll give you a hint, really good to use a model and count how many you get. So go ahead and knock this out. We'll let you work as a group. We'll give you guys 5 minutes. Find the answer to all 3 of these. Okay, on this one, hope you guys saw, if I just divide them into halves, I ended up with, guys, so 4 divided by 1/2 equals 8. When I divide it into 4s, 4 divided by 1/4 equaled 16. When I divided it into 1/3, 4 divided by thirds equals 12. So, how did the number of portions change as the size of the measuring scoop changed? What was that relationship?
So for the first two, it's going to be 8 and 16, and then 8 times 2 is 16, so it would just be times 2.
Okay, but how did the number of portions change as the measuring scoop size changed?
They're smaller.
What happened as it got smaller?
The number got bigger, but the portions are smaller.
The portions are smaller because I'm using a smaller scoop, but the number of portions got bigger. So, as the scoops got smaller, the portions got bigger. Okay, so analyze the three number sentences you wrote. Consider the relationship between the dividend, divisor, and quotient in each model. What patterns do you notice? Did anybody catch any patterns in this? Sophia?
The number's all the same. The dividend, it's always going to be 4.
Okay, dividend stayed the same, right? Dividend stayed the same. And then what happened? The dividend stayed the same. What happened to the divisor?
Oh, I'm doing for the last one.
The divisor got smaller. And although it got smaller, and then it got bigger again at the end, right? And then the portions, or the quotient, got bigger. Yes, they have. And I have been very consistent about anything I write on the board.
Definitely not what he has written on the board.
So, when my dividend stays the same, if my divisor gets smaller, my quotient gets bigger. In other words, I get more portions when I'm dividing by fractions. Is this making sense to everyone so far? Awesome. Let's go to page 10. All right. Slide 10 for me. It's page 48 for you. Page 48. We're going to give you guys, we'll say 4 minutes to do number 3. I will give you a hint. You're dividing each block into the number in the numerator, but then you're grouping it by the number in the denominator, but then grouping it by the number in the numerator.
Let's say that again.
So you're dividing it.
The denominator, grouping it by the numerator.
Got it? Okay, 5 minutes. I'm not Jesus. I'm Mr. Moore. Okay, guys, listen up. Guys, we only got a couple minutes left. So basically, this is the way this worked. Again, I looked at my denominator. That told me how much I was dividing each group into. So the first one, I was dividing into groups of 3. And I wanted to count it by groups of 2. So I have 1, 2, 3, 4, 5, 6 groups of 2. So 4 divided into 2/3 equaled 6. Now, mathematically, what did we just do? Again, mathematically, guys, I'll be straight up. Dividing by fractions makes no sense. We don't do it. Instead, we multiply by the reciprocal. So instead of dividing a fraction, I'm going to multiply by the reciprocal. What's the reciprocal of 2/3? 3/2. I just flip it up, guys. Flip it over upside down. Remember, when I'm doing a whole number, it becomes a 1. I can now do reductions. I have a power of 2 on top and bottom, so I can reduce that out. 3 times 2 is 6. 1 times 1 is 1. 4 divided by 2/3 equals 6. That's how we do it mathematically. We multiply by the reciprocal. Which actually, I'm going to go ahead and write that up here. So are we doing that or not? Ms. McShannon, am I putting the other phrase or not?
Multiply
Nope, the other phrase. Yes. Okay. So our next one. Now I'm dividing it into groups of 5. And I'm counting every 2. That gives me 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 4 divided by 2/5 equals 10. Doesn't make sense. Instead, I'm going to multiply by the reciprocal. I'm not going to reduce this time even though I could, but I want to show the other way. So 4 times 5 gives me 20. 1 times 2 equals 2. 20 divided by 2 equals 10. Did we get the same answer?
Yeah.
Might as well go to the bell. Okay. Homework tonight is just Mathia. All you're doing is the next module, which is representing fraction division. Okay? So by the end of tonight, you should have done the first 8 workspaces in Mathia. Or by the time you get back to class next time, I'll put it that way. You don't have to do it tonight. Okay, there's your bell. If you want.